There we go. Okay, hey everyone, and thank you for joining us today on a Thursday. Good morning, good afternoon, good evening, wherever you are in the world. We're super excited that you could join us today. We have Claire Byrne here speaking today, and she's going to be talking to us about the basics of blockchain security, a story of the very first Bitcoin case. And I will begin by introducing myself. So my name is Sapphire Duffy, and I'm a leadership fellow at WWCode, and I lead the data science and blockchain track with Naomi Freeman. And I'm also an AI engineer at Kainos Software, which is a UK company. And we have a few more offices around the world, but yeah, so that is a bit about me. And this is the blockchain team. So we have a good few leads and evangelists in our team at the minute, and the team are doing amazing work, and they're working really hard and leading our community. So a huge, massive appreciation to the team. And yeah, so for all of you that aren't familiar with the WWCode is a global nonprofit organization dedicated to inspiring women to excel in technology careers. We envision a world where women are proportionally representative as technical executives, founders, VCs, board members, and software engineers. And throughout the world, we have over 230,000 members, and we have 70 networks in 20 different countries, and we have members in over 97 countries. And so far, we have run over 2,000 events. And we give away daily conference tickets worth $1,025 worth and $2 million worth of scholarships. And we give you access to jobs and resources and infinite connections. And you can find a lot of this stuff here on the WWCode website. And yeah, our movement, so the world is in a really, really weird place at the minute, but we just want to let you all know that our community is here with you, and as the world changes, we can be a connecting force that creates a sense of belonging while we're all being asked to isolate. And this is a little bit of our code of conduct, so please take a look at it if you don't really know too much about it. But we follow a strict code of conduct that's embedded into our community, and we encourage our members to have an inclusive mindset. So if you feel, that something isn't right, or something's like not going the way you think it should be, please fill out an incident report, because we want this community to be as safe as possible and for everyone to, feel safe as well. And this is our track community. So we have 6 different track communities. We have blockchain, cloud, Python, mobile, data science, and front end. So really, we got a lot of requests from women who wanted to deep dive into technologies last year. So this is when the global track communities were created. So yeah, if you're not a member of the blockchain track, please do join us. So we run tech talks, workshops, tutorials, training, live stream events, study groups, and a whole lot of other things planned on the roadmap this year. But yeah, so I'll leave the links into the chat if you're not a member of our blockchain track. And today we have the amazing Claire Byrne. So Claire is an amazing woman in tech leader, and she is from Belfast, Northern Ireland. I've known Claire for quite some time now, and she's such an inspiration to me. And Claire is currently a software engineer in data engineering in a cybersecurity company, Rapid7. And she has completed an MSc in cybersecurity at Queen's University Belfast, and passing with a distinction, and is a massive cryptocurrency nerd. She has spent 5 years in leadership roles in the Belfast branch of the global nonprofit WWCode, which is us, woohoo, and is currently a global ambassador for our organisation. And she is a founder of the Google-sponsored Women Techmakers Belfast conference, and which has been running for 5 years now. And yeah, I personally see the amount of leadership that Claire has. Like, she has done so much for the Belfast community. And she is a co-founder of the InfoSec NI cybersecurity group, which is, I think, just recently started up, hasn't it, Claire?
Yeah,
which is really, really cool. I hope I'll be able to make one of those events in the future, because that's awesome. And she's also a board member of the NI Base 3 theaters company, and is an avid fiction writer. And in her rare moments of free time, she enjoys writing, singing, sipping tea, and playing Dungeons and Dragons with friends. Yeah, so that's awesome, Claire. So I'm going to pass it on over to you now. So I'm going to I'll stop sharing my screen here.
Okay, thanks, Zephyr. I'll share my screen here. Okay, can you see that, Zephyr?
Yeah, I can see your screen.
Okay, cool. All right then. Thanks for joining, everyone. So let me tell you a story today about the strangest place I've ever heard of. A dystopian futuristic place where, instead of humans mining for gold, computers do all the work. Farms of machines working tirelessly day and night, slaving at the mathematical grindstone, their efforts sometimes yielding a crypto asset. In this place, money has become more abstract as time goes on. It's evolved from being first rare metals to being the representation of rare metals, which are held by a centralized entity, like a bank, to being a decentralized, abstract mathematical asset that represents work, an idea, but also a very real thing. Have I lost you yet? I am, of course, talking about cryptocurrencies, and the place I was describing is right here and right now. You've probably heard of at least one cryptocurrency in the past few years. I'm guessing that one would be Bitcoin. Bitcoin has been around for just over 10 years, first starting in 2008, and becoming the pioneer of its rapidly growing field. There are a whole host of other cryptocurrencies out there, brought about by Bitcoin's success, some of them supporting startups that are working on blockchain technologies, some of them political statements to democratize investment and undermine centralized banks, and some of them simply jokes that are starting to be taken a little too seriously, such as Dogecoin and Garlic Coin. So these crypto assets aren't tied to any specific country like fiat currency is, and you can't tell who owns any particular asset. It's completely anonymous and decentralized, and not controlled by banks. Any transactions that are done using Bitcoin are crowdsourced, and there's no need or indeed no way to print bills or coins for these digital assets. So there's a couple of other neat features of cryptocurrencies as a whole. As I said before, they're mostly anonymous. However, all transactions in Bitcoin and crypto are public information. So when someone gives Bitcoin to another person, anyone can see that that money was moved, but they can't see who moved it. So how does one buy this magical digital currency? And why isn't everyone doing it? So anyone can purchase it, and there are cryptocurrency exchanges, just like there are actual currency exchanges. Once you've purchased your own Bitcoin, you can keep your digital money in the exchange itself or move it to a Bitcoin wallet, which can be stored on your computer or phone or somewhere else. And I'm going to tell you in just a few moments why this is an extremely good idea. So it seems like in recent years, investors all over the world have been swarming to buy Bitcoin, prompting some governments to step in with severe regulations leading to the big crash in late 2017. But through all the fuss and hubbub surrounding Bitcoin, many investors are still unsure about the security of the currency itself. Can Bitcoin be hacked? And if so, how can investors work to protect their investments? We shouldn't be surprised that security is one of the most worrisome issues in the cryptocurrency world. Blockchains are particularly attractive to thieves because fraudulent transactions can't be reversed very easily in the world of crypto, and they're difficult to trace and de-anonymize accurately. We've known for a long time that blockchains have unique security features, but on the other side of the coin, alongside those unique security features came a whole host of new security vulnerabilities just waiting to be discovered. Marketing slogans and headlines that called the technology unhackable were dead wrong. Recently, as the number of new cryptocurrency projects built on blockchain technology has begun to increase, we've started to see what poorly implemented design of cryptocurrencies can mean, and what the inherent theoretical weaknesses in these new security measures could mean for the future of digital assets. So then, I'll get to the burning question in everyone's minds. How do you hack a blockchain? Before we go any further, let's get a few terms straight. A A blockchain is a cryptographic database maintained by a network of computers, each of which stores a copy of the most up-to-date version of this database's transaction ledger. A blockchain protocol is a set of rules that dictate how the computers in the network, called nodes, should verify new transactions and add them to the database. The protocol employs cryptography, game theory, and economics to create incentives for the nodes to work towards securing the network, instead of attacking it for personal gain. If this is set up correctly, the system can make it extremely difficult and expensive to add false transactions, but relatively easy to verify valid ones. And that's what's made the technology so appealing to many industries, beginning with finance. Big financial giants are beginning to utilize blockchains in their existing financial systems, and even central banks are now looking into using them for new digital forms of national currency. But the more complex a blockchain system is, the more ways there are to make mistakes while setting it up. At the beginning of 2019, the company in charge of Zcash, a cryptocurrency that uses extremely complicated mathematics to let users transact even more privately than Bitcoin, they revealed that they'd secretly fixed a subtle cryptographic flaw accidentally baked into the protocol. An attacker could have exploited this to make unlimited counterfeit Zcash. Fortunately, no one seems to have done that this time around, but as with all vulnerabilities, if it hadn't been fixed, it was only a matter of time. So the cryptographic protocols behind the currencies aren't the only thing that has to be secure. To trade cryptocurrency on your own, or even run a node, you have to run a software client, which can also contain vulnerabilities. In September of 2018, developers of Bitcoin's main client, called Bitcoin Core, had to scramble to fix a bug that could have let attackers mint more Bitcoins than the system is supposed to allow. So admittedly, most of these recent headline-grabbing hacks weren't attacks on the blockchains themselves, but on exchanges, the websites where people can buy, trade, and hold cryptocurrencies. And many of those heists could be blamed on simply poor security practices, as we'll chat about later. However, that general trend of blockchains being ultra-secure changed in January 2019 with a 51% attack against the top 20 currency, Ethereum. So what's a 51% attack, I hear you ask? A 51% attack is an assault that can be launched on the proof-of-work protocol that makes up the very philosophy of cryptocurrency as we know it. But before we define an attack on this protocol, I'd better explain what it is. Essentially, proof of work is used to determine how the blockchain reaches consensus. In other words, how the network can be sure that a transaction is valid and that someone isn't trying to do bad things, such as spend the same funds twice. With systems like blockchain-backed cryptocurrency, which are sometimes called trustless decentralized systems, everyone has a copy of the ledger that stores transaction records, so no one has to trust in third parties, because anyone can directly verify that the information is true. So every block on the blockchain contains the same transactions within it, which have to be independently verified. So for the Bitcoin network to achieve this without a third party, someone has to use computational power to solve a cryptographic algorithm, otherwise known as proof of work. So this mathematical puzzle generally has a key feature, which is asymmetry. The work has to be moderately hard on the requester side, but easy to check for the network. So this idea is known as a computational puzzle, and from a technical point of view, the mining process is an operation called inverse hashing. So a number is determined. So the cryptographic hash algorithm of block data results in less than a given threshold, which is sometimes called the difficulty. So this is what determines the competitive nature of mining. More computing power is added to the network, and as this happens, the parameter increases, increasing the average number of calculations needed to create a new block. So this also increases the cost of block creation, pushing miners to improve the efficiency of their mining systems, and it's all just a big exponential increase, increasing difficulty, etc. So that's generally the advantage of buying a load of expensive hardware and consuming lots of electricity. You get additional Bitcoin, you're rewarded with that for your efforts. But the most important thing to understand here is not everybody gets a reward. So there's thousands of individual devices competing to become the first to solve this cryptographic algorithm. And whoever gets there first wins the reward. So whoever owns the biggest computational power has more chance of being the winner. So as you can see, one of the major issues with the proof of work protocol is that it isn't a fair system, because those with the most powerful and expensive hardware devices will always have the greatest chance of winning. So proof of work is an amazing invention in some regards, but it's anything but perfect. Not only does it need significant amounts of electricity, but it's also very limited in the amount of transactions it can process at the same time. So then, back to 51% attacks. So this is one of the major downsides I mentioned to the much-loved inherent security of blockchains. A miner who somehow gains control of a majority of the network's mining power can defraud other users by sending them payments, and then creating an alternative version of the blockchain in which these payments never happened. So this new version is called a fork. The attacker who controls most of the mining power can make the fork the authoritative version of the chain, and then just proceed to spend the same cryptocurrency again. So for popular blockchains, attempting this sort of heist is likely to be expensive. According to the website Crypto51, renting enough mining power to attack Bitcoin would currently cost more than $260,000 per hour. But it gets much cheaper very quickly as you move down the list of the more than 1,500 cryptocurrencies out there. If you've ever looked on a Bitcoin exchange, there's loads of them, and some of them are extremely cheap. So slumping coin prices make it even less expensive to try and launch a 51% attack. So towards the middle of 2018, attackers began springing 51% attacks on a series of relatively small, lightly traded coins, including Verge, Monacoin, and Bitcoin Gold, stealing an estimated 20 million in total. So the hit against Ethereum Classic, which was also a 51% attack, they lost more than $1 million. And this was the first attack of its kind against a top 20 currency. So aside from 51% attacks, there are a whole new level of blockchain security weaknesses whose implications researchers are just beginning to explore. Smart contract bugs. A smart contract is a computer program that runs on a blockchain network. It can be used to automate the movement of cryptocurrency according to a set of rules. So this has many potential uses, like facilitating legal contracts or other complicated financial transactions. One use is to create a voting mechanism by which all investors in a venture capital fund can collectively decide how to allocate money. So I bring this case up because it's a case of interest. So this happened in 2016, and this fund was called the Decentralized Autonomous Organization, and it was backed with Ethereum. So shortly after this was created, an attacker stole more than $60 million worth of cryptocurrency, exploiting an unforeseen flaw in the smart contract that governed this organization. So essentially, this flaw allowed the attacker to keep requesting money from accounts without the system registering that the money had already been withdrawn. So a bug in a live smart contract can create a unique sort of emergency, I guess. In traditional software, how do you fix something? A patch. But in blockchain, it's not so simple. Transactions on a blockchain can't be so easily undone. There are fixes of a sort. Smart contracts can be upgraded by deploying additional smart contracts to interact with them. And developers can also build centralized kill switches into a network to stop all activity once a hack is detected, But for users whose money has already been stolen, that'll be too late. The only way to retrieve the money is effectively to rewrite history. So to go back to the point on the blockchain, before the attack happened, create a fork to the new blockchain and have everyone on the network agree to use that one instead. So that's what Ethereum's developers chose to do when this happened. Most, but not all, of the community switched to the new chain, which we now know as just Ethereum. And a smaller group of holdouts stuck with the original chain, which became Ethereum Classic. So tens of thousands of smart contracts may contain some other kind of vulnerability, according to research conducted last year. And the very nature of public blockchains means that if a smart contract bug exists, attackers are going to find it, since the source code is often visible on the blockchain. So I guess it's just a case of waiting. Ethereum is definitely one to watch, though, and soon they'll be launching Ethereum 2.0, with their final test network having been deployed on August 4th there. So this network is abandoning the proof of work class of protocols and moving to something called proof of stake, which is super interesting. Proof of stake? Okay, terrible joke, sorry. I had to get one in there. So proof of stake, it represents a class of consensus algorithms in which validators vote on the next block. And the weight of the vote depends on the size of its stake, or the amount of coins that someone has in the network, or the amount of currency, I guess. It's considered an overall improvement over proof of work because it uses less electricity. There's reduced risk of centralization, and it maintains security against different types of 51% attacks. The proof of stake model uses a different process to confirm transactions and reach consensus. The system still uses a cryptographic algorithm, but the objective of the mechanism is different. So proof of work rewards its miners for solving complex equations. In proof of stake, the individual that creates the next block is based on how much they've staked. So basically how big their hand is in the network. So technically, individuals aren't mining in this case. Instead, they're forging because I guess there's no block reward. In the proof of work model, obviously, a block reward is issued every time a new block is verified. But those who contribute to the proof of stake system simply earn the transaction fee. So how does this work then? So firstly, to have the opportunity to validate transactions on this blockchain, a user must put their coins into a specific wallet. This wallet freezes the coins, meaning that these coins have now become the stake, and they're being used to stake the network. Most proofs of stake blockchains have a minimum requirement of coins, which of course requires a large upfront investment. And when I say large, I mean thousands to millions of dollars large. So I guess to clarify, proof of work requires all of its miners to attempt to solve a complex sum, with the winner determined by the person who has the most powerful hardware devices, I guess. Whereas the proof of stake model randomly chooses the winner based on the amount they've staked, with larger stakes having a higher chance of getting the reward. So it's still not completely fair, but it's getting there. So technically, I guess, an equivalent of a 51% attack against a proof of stake network is possible, but it's more difficult. So I hope that these examples illustrate the fact that cryptocurrency is difficult to hack, but it's not necessarily impossible. It can be riddled with technical and human errors. So we've gone over a few of the technical vulnerabilities. However, in every cybersecurity system, humans are always the biggest weakness in the chain. I'm going to tell you a very short story of the very first Bitcoin heist and the catastrophic financial cost of human error from the disasters that occurred on Mt. Gox. Mt. Gox. It sounds like something straight out of a Zelda game or a Terry Pratchett novel. This was the name of the very first Bitcoin exchange that was set up in 2010 by a web developer named Jed McCaleb. So named because the domain was previously used as a Magic the Gathering online exchange. For a year, it grew and grew. It was the first of its kind. People needed a place like this to buy and sell this new crypto asset that was being talked about in the underground of the internet. So Jed McCaleb wrote the whole thing himself. It was his magnum opus, and within a short time, he began seeing the fruits of his labor. But in 2011, disaster struck. Two vulnerabilities that Jed had unwittingly left in his code were exploited. So the first of these involved Liberty Reserve, which was a company that Mt. Gox had used to transfer money from one person to another over the internet. Mr. McCaleb had made a mistake when adding this service to his web app. The gist of the exploit was that a user would be able to inject XML to override parameters in the API request sent in order to get more money than they actually withdrew from the exchange. You can probably see how this would cause problems. And that wasn't the only bug in Mr. McCaleb's code. The transaction system as a whole didn't sanitize input. Pretty sure that's one of the OWASP top 10s. It accepted negative inputs, allowing users to withdraw money when they should be depositing it. By the time Jed had found these bugs, he had already lost $50,000. So he began talking to friends to try and sell this site, realizing that he was taking more time and money than he could afford to put into it. One of his friends, a man named Mark Carpeles, accepted the sale of the site. Having been told that Jed was unsure of the legality of Mt. Gox in terms of international financial law, and also having been told about the recently patched vulnerabilities and warned that there might be more. But he got Mt. Gox at a good price, so that's all that matters, right? So just before the transfer of ownership to Mr. Carpeles, something happened to Mt. Gox. Someone had broken into the Mt. Gox servers and stolen the hot wallet file, transferring all the coins in it to their own wallet. So hot wallet is the Bitcoin wallet Mt. Gox used to conduct daily operational trades. This differs from a cold wallet, which is not stored on the servers, but in another location in a much safer place. So the thief that day took about 80,000 Bitcoins and disappeared. And these are actually sitting untouched on the blockchain to this day. So it's quite possible that they've been accidentally destroyed, or they could be sitting in a hard drive in a dump somewhere, just waiting to be found. But what this meant for Mt. Gox was it was now insolvent. That is, if all the Mt. Gox users were to try and take their Bitcoins out of the exchange, there wouldn't be enough for everybody. There was a lot of money missing by the time Mark Carpeles took over the exchange, which was not the greatest start to his management. So Mr. Carpeles was in the process of figuring out where the Mt. Gox Bitcoins should be stored. He had some in the exchange servers in the form of a hot wallet, and he had some in a secure offline location. All good so far. But he also had some on his personal computer. Hands up if you think that was a good idea. I'm assuming everyone has their hands up. So during this time, it appears that somebody was able to get into Mark Carpeles' own personal computer, which appears to have been quite unsecured. And at the time, he was unfortunately keeping 300,000 Bitcoins from Mt. Gox on his own unsecured machine. The thief he just got lucky and found it and ran away with it. So a lot more of this sort of thing happened, but I'll keep it short because I'm sure you get the gist. And by summer of 2013, Mt. Gox had lost nearly 800,000 Bitcoins to theft and hacking. So if you think of that in today's value, one Bitcoin is worth, what, about $8,000 at the minute? Maybe? As it turns out, Mark Carpeles should have asked a few more legal questions before taking on ownership of Mt. Gox. They'd been in violation of acting as an unregistered money transmitter in the US. And in total, the Department for Homeland Security seized $5 million from Mt. Gox. It was also discovered that Mark Carpeles was running a trading bot, which was one of the final nails in their coffin. So in February 2014, Mt. Gox shut down entirely. The largest Bitcoin exchange in the market just halted. People just couldn't grasp how such a large amount of Bitcoins could just become lost like that. But it was, just not all at once. So what have we learned? Well, it's definitely not a good idea to leave your cryptocurrency on the exchange unless you're actually trading it. It's also best to keep an encrypted Bitcoin wallet on your own computer that you control and which is secured. Or even better, store it in a hardware wallet that you keep on your person or in a safe. I know I sound paranoid, but as you've seen, you really need to be careful to protect your assets from thieves. So make sure you back up your wallet keys regularly, make sure to use strong passwords, and avoid making crypto trades on public Wi-Fi networks or with dodgy browser extensions installed. So as we've seen, cryptocurrency can be stolen from an exchange. So when choosing an exchange to purchase from, it's really good to see if it complies with audits for exchanges to operate in the US and the UK and beyond, as they must adhere to strict audits. It's also good to use an exchange that has a good reputation and to use two-factor authentication where possible. Another tip is to watch out for scams, I guess. So they're absolutely everywhere. But honestly, I found personally that the cryptocurrency subreddit is a good resource for checking if a service is reliable and trustworthy. They have extremely strict rules about posting to the forum, and so they tend to weed out illegitimate schemes pretty quickly. So cryptocurrencies promise the world more economic freedom, partly because they're designed to shift control back to the people using it, away from centralized entities like governments and banks. However, with increased freedom comes increased responsibility, which means that you yourself are responsible for the safety and security of your purchased cryptocurrencies. The security of a system is only as strong as its weakest link. Will you be the weakest link? Thank you. And feel free to send any questions to any of these contact details. That's me.
Awesome. Thank you so much, Claire. That was really, really great. Yeah, so like Claire said, if you have any questions, just please email her. Claire, could you put your email in the chat? So
yep, I'll put all.
Can access that. Thank you. And this will also be recorded as well, everyone. So if you want to watch back again, or if you want to, watch it again, it will be posted on YouTube probably either this week or the early next week. Awesome, thanks, Claire. I just see you posted your details in there in the chat.
Just copy paste my LinkedIn as well here. But yeah, thank you for listening, everyone. Really appreciate it. I know I went on for quite a long time there.
No, it was absolutely perfect. I learned so much. Like, I don't know my background. I don't really come from blockchain background, but I've learned a lot in your talk. So thank you, Claire. I'm sure a lot of our attendees here have as well. I'm going to start sharing the closing slides here for everyone. There we go. I'm going to ask you, Claire, can you see my screen? Perfect. Okay. So yeah, Claire, thank you very much for your talk today. Again, everyone, Claire has the details in the chat there if you want to reach out to her. So we have an exciting event coming up next Tuesday. It's called Bites and Brew. So Bites and Brew is an event where we can connect with each other, network with each other, make cozy conversations at your own home and make new friends. If you need any career advice, or want to ask anyone about anything like to do with your job, or even if you want to talk about animals or whatever you want to, yeah. So this is just like basically for us to for our whole community to get together and get to know each other. And this is you can register for this event using this link here. So it's bit.ly/bites and brew. We're running at 2 different times. It's at all time zones. So there's one at 3 a.m. EST and 12 p.m. EST. So if you just use like a worldbuddy.com, and you'll be able to type in your time zone and the EST time zone and see what time it is for you. But yeah, we're super excited for this event because originally this event came from Belfast, the Belfast chapter. So now it's it was really successful in our chapter in Belfast, so we really want to bring this to a global level, so a global level event. So, yeah, we really can't wait for it. We're excited to meet you all. So yeah, if you haven't heard of Applaud Her, so Applaud Her to Claire today for her talk. It was amazing. So Applaud Hers are acknowledgements of professional accomplishments, such as obtaining a new job, receiving a promotion in work, speaking at a conference, speaking at like one of our webinars that Claire has here today, learning a new programming language, or like, you know, stepping up as a Women in Code leader in your network, or anything that is a huge achievement, or like small achievements in your life. Yeah, so Applaud Hers can be submitted for yourself or others at womenycode.com/applaud her. And yeah, so we're actually growing, sorry, this is data science, but it's blockchain and data science. We're growing both of our tracks at the minute, and we are looking for volunteers for both tracks. So if you're interested, please email me here at staff@womenycode.com, and I will then send you an invite to your next onboarding session and get to know a wee bit more about you and what you're interested in. We would love to hear from you. Yeah, so you can follow us here at womenycode.com/blockchain. You can register as a member for our track. And if you want to email us, it's blockchain@womenycode.com. And here's our social media pages as well. We have a Twitter page, an Instagram page, and we also have a LinkedIn as well, which was recently set up. So if you want to maybe take a screenshot here of our pages to follow us. I'll give you a few seconds. There we go. And yeah, that's us coming to an end today. But yeah, thank you everyone for joining today. We really appreciate you coming along. And thank you again, Claire. I hope everyone has a great day.
Thanks, Zephyr.
Thank you.
I just realized I hadn't, I'd only sent my contact details to all panelists, so that was just you and me.
Oh, no.
So I just sent it to everyone now, so that's good. Right.
There we go. That's good then. Okay, awesome. So once I close this, actually, it'll end the chat and nobody will see it. So I guess I'll leave it on for a few more seconds so people can take your details there.
Okay, we'll hang around for a while.
So you probably heard Leno there scratching the door there, Claire.
Oh.
He always does this around this time. I'm like, no, shh.
Oh, he just wants dinner.
I know. How's your guinea pigs?
Yeah, they're grand. Yeah, the fluffy one is being really fluffy at the minute. I need to give him a bath.
Oh. Oh, how are they coping with the weather at the minute?
Yeah, they're not really liking the rain, to be honest.
Yeah, I know. Times like this year is quite scary for animals, especially when there's like, you know, thunder. But I haven't had any of that yet.
My goodness.
Yeah.
Right.
But yes, I guess we'll end here now. But yeah, I'll speak to you soon. Thank you everyone again.
Right. Thanks.
Bye.
Bye.